In this video, we are going to create a simple database using vector CANDB++ editor. So the database will be in this structure as message as vehicle status and the signal, these four signals: speed, which is vehicle speed; RPM, which is the engine revolution per minute; and the gear position as parking, reverse, neutral, and the drive modes; and the fuel level, uh, 0 to 100 percentage, and this kind of data we are going to create. Now in this vector CANDB++ editor, click on file, create database. Now can template.abc and click OK. Let us name it as simple vehicle database structure. So here can fill the gap using underscore, or let it be without spacing. I'm going to save it in documents, so save it. So this is the outline of this simple vehicle DBC structure. Now we are going to add these signals: speed, RPM, gear position, fuel level, engine temperature, oil pressure, and throttle position. Just we are going to neglect these two for the demo purpose. So in the signal, right click and click on new and rename this new signal 1 as speed, and the type as unsigned. The unit will be kilometer per hour, and the minimum value is 0 and maximum value will be 250 kilometer per hour, and click apply and OK. So we can see the signal speed is added, created, and repeat the steps for creating the rest. RPM unsigned, the maximum value is going to be 8000 RPM. So 8 into, that is 8 times 1000 RPM. So this is the speed, that is RPM of the engine. So 8 into 1000, 8 times 1000 RPM. Apply OK, and then the next signal, gear position, and so here we have signed, assigned, float and double only, no enum. So we are going to use the same unassigned, and first gear to fifth gear, 1 2 3 4 5 gears. So no need to add reverse gear, this is for demo only. So apply OK, and the next signal, fuel level, unsigned, unit will be percentage. We are going to take this fuel level in percentage, 0 to 100 percentage. OK, the next signal going to engine temperature, engine temperature, this is also going to be assigned. The minimum temperature is going to 40 and maximum is 150. Unit will be Celsius, and click apply OK. The very next signal is the oil pressure. Unsigned, oil pressure is, its unit is PSI, 0 to 100 PSI. OK, and the next signal is throttle position, which is the intake valve position, air intake valve position at this, at the engine. It's going to 0 to 100 percentage. How much it's the valve is opened like that. Click OK and let us add this battery voltage also. We can add battery voltage. Battery voltage. Let it be unsigned also, not float. Voltage, volt. The voltage is the unit of voltage is volt. So 0 to 14 volt. Let it be 14 volt. Let it be 12 volt. So in practical, the battery voltage will be up to 14 volt. That will be 14 volt. Can apply. Okay, we added 8 signals. Now we are going to add the messages. The first message is vehicle status. Vehicle status. Okay, vehicle status, and the message ID I am going to give it as 100. And in the signals tab, add the vehicle status signals like speed, RPM, gear position, and fuel level. By holding the control button, we can select multiple signals at a time. So no need to add it individually. So these 4 signals are selected and click OK. So you can see these 4 signals are added to this new message one, that is vehicle status. Apply. Then OK. So you can see the vehicle status message. Under this vehicle status message we have 4 signals. So add new message. Next message is engine data, and the ID will be 110. Apply signals. We can add that throttle position. By holding the control button, we can select multiple data. Yeah, these 3 are going to in engine data. And apply and click OK. See, you can see these 3 signals in the engine data. And battery info. Let this ID be 120 and then apply, and I'm going to add the signal battery voltage. Yeah, so you can see this battery voltage in the message. Under the message battery info, apply OK. Then we are going to create a new node. This is ECU node, let it be the name. And transmit messages, we are going to add these 3 messages by selecting all these. You can see these 3 messages added to this particular node. Apply OK. You can see this. So now we successfully created a simple vehicle database structure using these 8 signals and 3 messages and a single node. By clicking on this icon or by clicking Ctrl S, we can save this database. Now we are going to open the TSMaster and we are going to simulate this database. Now create a empty project in this TSMaster, and we can add the database just now created from the analysis tab. Database, show CAN database. in channel 1, right click on it and the load database, load CANDB. In this we are going to search for the database just now created. Yes, here simple vehicle database structure and click open. We loaded this database in TSMaster. So we can see there's 8 signals and 3 messages, and this node we have created here. Then I'm going to add the transmit window and trace window. Both are under the analysis tab. I'm going to arrange this so that we can access both transmit window and the trace window. Yes. Okay. Now by clicking this icon in the transmit window, we can add these 3 messages by selecting, by holding the control button. You can select these 3 simultaneously, apply, OK. Now I'm going to click on this button or just start the simulation, and we can press this button to set all the CAN messages. But you can see there is no message data, that signal data, there is no signal data, all are 0. So we didn't give any data here. So now in this fuel level I'm going to give it, fuel level will be the percentage. So we have 75% of fuel, and the gear position is third gear, and the RPM is going to be 7000 RPM, something 7 into 1000, so 7000 RPM, and the speed will be around 80. Okay, as like that we can change this engine temperature around 95 degrees Celsius, and the oil pressure around 90 psi, and the throttle position is around 50. And the same, the battery voltage info was 12 volt, let it be the 12 volt. Now I'm going to click this button, start sending all CAN messages. Now we can see this message we have sent here. Yeah, so all the messages are transmitted with that we are tracing this in the trace window. So here we can log this too. For logging purpose I'm going to set the timer so that the simulation is going to be automated. Yeah, and this generator we can create sine waves, ramp and pulses, value range, toggle and random. I'm going to select random for fuel level, for then random for gear position also, RPM for gear position, for random for RPM also, and the random for speed also. Now let us give value range for speed, and by clicking the settings icon you can see steps, holding time, minimum and maximum. Maximum will be 250 in our case. So then click apply, and then close. The same here, RPM will be 8, the higher value will be 8. Apply, close. Gear position, the higher value will be 5. Apply, close. And the fuel level, the higher value will be 100. Apply, close. So by clicking apply we can see the value changing here. The same is going to do here also. The engine temperature will be random, this oil pressure random, throttle position is going to vehicle sorry, value range. So the value range 100, okay, 100 by default, it will be apply, just close. Oil pressure random, oil pressure will be 100, 0 to 100 psi, apply, close. Engine temperature is going to, the low value will be around 90 to 105, it will be. And then for battery voltage also, we are not going to change the battery voltage since it will be 12. Yeah, okay, now we can send this. You can see the values are changing. We can start logging, and this value changing will be recorded. Let us record for some 15 to 20 seconds. Okay, we can stop this and go for this. We can stop the simulation also and go to this log directory. We can see the .blf file, which we cannot read this because this is a machine language, which will be something like this. So we are going to convert this .blf file to .asf file. So I'm going to copy this address, this location of this file, just by Control C. So full address, Control C, and then close it. Log converter. Here I'm going to open this file. Here just paste it and click on this arrow icon. We can see this .blf file. Select it and click on open. So we can see the full address of this file, and here destination file will be .eac format. This .blf file is going to convert into .eac format. Just convert. This directory will be automatically open, or we can simply click on log directory, it will be open like this. So this is the .eac file format. We can see this via notepad. Just right click and open with notepad just once. Yes, we are the data logged here is recorded here. You can see these are all the data from the message ID 110 and 100 and 120. You can see this 100 is the vehicle status message, and the 110 ID is engine data message, and the 120 ID is battery info message. Here the messages are in hexadecimal format, and that's all. Thank you. We successfully created a database in this video CAN database and simulated it by using the TSMaster, and we recorded the events. We logged the events. Thank you.